Okay, so have you ever felt overwhelmed?
Mm.
Like, you know you're trying to learn something new and there's just too much.
Yeah, like suddenly it's an avalanche of information, right? Walls of text and complicated diagrams and
Yeah. And maybe even like, videos with all those flashing graphics and
yeah,
things.
you're bombarded. It's like a fire hose of data.
Right. It's like your brain is trying to sprint a marathon or something.
I think we've all been there.
Totally. And on the deep dive, we get that.
Yeah, we really try to cut through the noise.
We take all those sources, all those overwhelming things, and boil it down to the good stuff.
Exactly, the stuff that's actually important.
Stuff that really sticks so you can understand a topic, thoroughly.
Without completely frying your brain in the process.
Without feeling like your brain is totally fried, right?
Right. Like you've actually learned something, not just had information thrown at you.
Exactly. So today, we're diving into something that's really at the heart of how we learn.
Yeah, this is a big one.
How does our working memory, that mental workspace we use all the time?
Our brain's RAM, basically.
Right. Exactly. How does it handle learning when we're looking at both text and pictures?
Because that's a lot of what learning is these days, right?
It is. It's everywhere.
Textbooks, online courses, presentations,
Pretty much, yeah.
all of it.
So we've been really digging deep into a research review that tackles this exact question.
A really fascinating one.
Really fascinating. It's called The Role of Working Memory in Multimedia Instruction. Is working memory working during learning from text and pictures?
Quite a mouthful.
It is a little bit, yeah. But it's all about, kind of understanding what our minds are doing when we engage with multimedia.
Peeking under the hood.
Peeking under the hood, right. Like when you're, in an online course that's full of visuals and text.
Or even just scrolling through social media.
Right, exactly. And this isn't just, some abstract theoretical thing.
Oh, no, this is very practical.
This is very practical. This has implications for how you learn best.
Absolutely.
And how materials can be designed to actually help you learn exactly if we know how the engine works.
We can make it run better.
We can optimize the learning.
Right. So for this deep dive, we're focusing on a scholarly article.
It's a comprehensive review of a ton of existing research.
So really thorough.
Really thorough. Yeah, and our mission today is pretty straightforward.
Lay it on us.
We want to understand the current scientific thinking about how working memory functions.
Specifically.
When we're learning from both text and pictures.
Okay, cool. So, where do we even begin with all of this? I feel like we need to start with some kind of framework, a model of working memory.
Absolutely. And thankfully, there's a really influential model that kind of lays the groundwork for a lot of this thinking.
Okay.
Baddeley's model of working memory.
Baddeley's model. Okay, so what's the gist? What's the big idea here?
So Baddeley basically said that working memory isn't just one big container where we hold information.
Yeah.
It's more like a team of specialists, each with their own specific role.
Okay, interesting. So like a team of players.
Thanks.
Okay, so who are these players? What are their roles?
All right, so first up, you've got the phonological loop, or PL.
The PL? Okay.
This is basically your inner voice and your inner ear working together.
Okay.
So it's primarily responsible for processing verbal information.
So anything language-based?
Yeah. So when you hear someone speaking or when you read words, that information gets processed in the phonological loop.
Interesting. And so even when I'm reading silently to myself.
Even then, a lot of times those written words get converted into a kind of internal speech.
Like subvocalization.
Yeah, before it even enters the loop.
Okay, so that's fascinating. So if I'm, listening to a lecture or reading a textbook, my phonological loop is going to be pretty busy.
Oh, absolutely. That's its bread and butter.
Right. Okay, cool. So that's the PL. What's next?
All right, next up is the visuospatial sketchpad, or VSSP.
Okay, VSSP.
This is basically your mind's eye.
Okay.
It's the part of working memory that handles visual and spatial information.
So the stuff that I see.
Exactly. So things like shapes, colors, that's the visual aspect.
Okay.
And then the spatial part deals with things like where things are in relation to each other.
Right.
Your sense of direction, even how you imagine moving through space.
Okay, so that's pretty important.
Hugely important.
Okay, so when I'm looking at, diagrams or charts or, any kind of image.
Any kind of visual information, that's when the VSSP kicks in.
Okay, so lots of visuals equals busy VSSP.
That's the gist of it.
All right, I'm starting to get this. So we've got PL for words, VSSP for visuals and spatial stuff.
Right.
Now, is there someone who kind of manages all of this, who makes sure it all works together?
You bet there is. That's where the central executive comes in, or the CE.
The CE. Okay.
This is basically the control center of working memory.
Okay. The boss.
Exactly. It's responsible for a whole bunch of critical functions.
Like what?
Well, first of all, it monitors and coordinates the activities of the phonological loop and the visuospatial sketchpad.
So making sure they're not stepping on each other's toes.
Exactly. It's also the bridge between working memory and your long-term memory. So it helps to link up new information with what you already know.
Makes sense.
The central executive is also what allows you to switch your attention between different things,
Okay.
to allocate your mental resources to decide what to focus on.
It's like the project manager of the brain.
A very apt analogy.
Cool. So the central executive, it's coordinating, it's connecting, it's allocating resources. Anything else?
Yeah, it also plays a role in updating the information you're holding in working memory.
Right.
And it even helps to keep track of when and where you learned certain things.
Wow. So it's really involved in a lot.
It is. It's a very busy part of your brain.
Okay. So we've got these three key players: PL, VSSP, CE. Are we missing anyone?
There's one more that was added a bit later to the model,
Okay.
like the episodic buffer.
The episodic buffer. What's that one all about?
So Baddeley realized that the central executive itself didn't have its own dedicated storage space.
Okay.
So he introduced the episodic buffer as a kind of temporary storage area
Are they?
that can hold information in a combined format.
So it can integrate stuff from the PL and the VSSP.
Exactly, and even pull in relevant stuff from long-term memory.
Oh, wow. Okay. So it's kind of like a melting pot where everything comes together.
That's a good way to think about it.
Okay. And the central executive still oversees all of this, right?
Right. It's still the one in charge deciding what goes into the buffer and what comes out.
So it's like a workspace where different pieces can be combined and manipulated.
Precisely.
Okay, this is fascinating. So to recap, we have the phonological loop for verbal stuff, the visual spatial sketchpad for visuals and spatial stuff, the central executive as a coordinator, the boss, and then the episodic buffer as this temporary integration and storage space.
Ah, that's a great summary.
Thanks. Okay, so how does all of this relate to how we learn from multimedia, specifically when we're dealing with both text and pictures?
Right. So Baddeley's model gives us a few really crucial insights.
Okay.
First, each of these components has limited capacity. They can only handle so much at once.
Okay, like a computer with limited RAM.
Exactly. If we overload any of them while we're trying to learn, it's going to affect how well we process and remember information.
That makes sense. So like if I'm trying to read a dense textbook while also looking at a complicated diagram.
Yeah, you might be overloading both your phonological loop and your visuospatial sketchpad.
And then I won't learn as effectively.
Exactly. Your working memory is like a juggler trying to keep too many balls in the air at once.
And some are going to drop.
Inevitably.
Okay, so the second insight then.
The second insight is that the impact of these limitations depends on which part of working memory is struggling.
Okay, so it matters which player is getting overwhelmed.
Exactly. Overwhelming the phonological loop will mainly affect how we process spoken or written words,
Right.
while overloading the visuospatial sketchpad will affect how we handle images and spatial stuff.
Okay, that makes sense.
And then the third crucial insight:
Hit me.
the central executive and the episodic buffer are absolutely essential for taking all that verbal and pictorial information and weaving it together into a meaningful understanding.
So it's not enough to just process the words and pictures separately.
No, they need to be integrated.
Right.
And if the central executive and episodic buffer are taxed too heavily, that integration process suffers and you won't learn as well.
Okay, that's a really important point. So when we're bombarded with information in different formats, our working memory is trying to juggle all these different pieces, and if there are too many, some are bound to fall.
Perfect analogy.
Okay, so we've got this foundational model of working memory. Now, how does this connect to specific theories about learning with multimedia?
Right, so these ideas about working memory have really shaped a lot of the thinking in multimedia learning.
Okay.
And there are two prominent theories that build on Baddeley's model, although they apply the ideas in slightly different ways.
Okay, which ones?
The cognitive theory of multimedia learning and cognitive load theory.
Okay, so let's start with the cognitive theory of multimedia learning. How does it view the role of working memory when we're learning from text and pictures?
All right, so this theory proposes that we essentially have two main channels for processing information,
Okay, two channels.
an auditory verbal channel and a visual pictorial channel.
Okay, so like two separate pathways.
Exactly. And the idea is that we process spoken words through the auditory verbal channel and visual information like pictures and diagrams through the visual pictorial channel.
Okay, so that kind of makes sense. It's like how we have different senses for taking in information.
Exactly. And the champion of this theory, Richard Mayer, he suggests that these separate channels align with Baddeley's distinction between the visuospatial sketchpad for visual and the phonological loop for verbal information.
Okay, so it's like they're mapping those channels onto those specific working memory components.
Right. And the idea is that multimedia learning works best when we can process the verbal and visual information separately in these channels and then integrate it all together.
Okay, so like parallel processing followed by integration.
Exactly.
But you mentioned earlier that there might be a bit of a mismatch between these theories in terms of how they define those channels.
Right. So this is where things get a little bit tricky.
Okay, on all ears.
So according to Baddeley's original model, the main distinction between the phonological loop and the visuospatial sketchpad isn't really about whether the information comes in through our ears or our eyes.
Okay.
It's more about the type of information itself, verbal versus pictorial.
Ah, I see.
So the cognitive theory of multimedia learning's focus on the sensory mode auditory versus visual as the key difference.
Right.
It's not completely in line with how Baddeley initially framed it.
Interesting. So even though spoken words come in through our ears, they're still processed in the verbal part of working memory, the phonological loop.
Exactly. Not necessarily in a totally separate auditory channel.
Right, right. Okay, so that's a nuance that's worth noting. So a bit of a branching point there between the theories.
Definitely.
Okay, so what about cognitive load theory? How does it bring in the concept of working memory?
So cognitive load theory puts a lot of emphasis on the idea that our working memory has a limited capacity overall.
Okay, like a limited amount of mental energy or resources.
Right. And it talks about different types of cognitive load that affect how we learn.
Okay, what are those?
So there's intrinsic load, which is the inherent difficulty of the material itself.
Okay, so that depends on the complexity of the information and how much I already know about it.
Exactly. Then there's extraneous load, which is the cognitive effort that's imposed by poorly designed instruction.
So like confusing layouts or unnecessary distractions.
Exactly. Things that don't actually help you learn.
Okay, so we want to minimize that one.
Absolutely. And then there's germane load,
Germane load.
which is the effort you put into actually making sense of the material.
So like making connections, building mental models.
Exactly, that deeper processing
Okay, so we want to maximize germane load.
as much as possible.
Okay, so it sounds like cognitive load theory is saying that learning gets harder when the total amount of these different loads exceeds the capacity of our working memory.
Right, it's like trying to run too many programs on a computer with limited RAM.
Exactly, the computer crashes.
The brain crashes.
Or at least slows down a lot.
Right, it can't function as efficiently.
Okay, that makes sense. So how does cognitive load theory relate to Baddeley's specific working memory components?
So unlike the cognitive theory of multimedia learning with its dual channels,
Right.
cognitive load theory doesn't always map as neatly onto those separate subsystems, the PL, VSSP, and CE.
Okay.
It often treats cognitive resources as more of a general pool.
Okay, so like a single bucket of resources.
Right. But there is one main exception
What's that?
when cognitive load theory talks about the modality effect,
The modality effect.
which we'll get to in a bit. But in that context, it does differentiate between auditory and visual working memory resources.
Okay, so there it aligns more with the dual channel idea.
Exactly.
So it sounds like both of these theories, cognitive theory of multimedia learning and cognitive load theory, they both acknowledge that working memory is really important
Absolutely crucial.
and that it has limitations,
Right.
but they have slightly different perspectives on how those limitations play out.
And neither of them really digs deep into the specific roles of the central executive or the episodic buffer in that integration process.
Right, that active process of bringing the verbal and pictorial information together.
Even though they both say that integration is super important for learning.
Right, like essential.
But according to Baddeley, it's really the central executive working with the episodic buffer that's doing the heavy lifting there.
Okay, so coordinating those subsystems, making connections with long-term memory holding, and manipulating that combined information.
Exactly.
So there are these interesting points of overlap and divergence between these different theories,
Definitely.
which I think raises the question of how do researchers actually study this stuff?
Yeah, how do we actually figure out what role working memory is playing when we learn from multimedia?
Right, because it's not like we can just look inside someone's brain and see those gears turning.
Not yet, at least.
Right, so what kind of methods are researchers using?
So there are two main approaches that they use to investigate the involvement of working memory in multimedia learning:
Okay, what are they?
the capacity approach and the dual task approach.
Okay, so two different ways of tackling this problem.
Exactly.
All right, so let's start with the capacity approach. What's the basic idea there?
So the capacity approach is all about measuring individual differences in working memory capacity.
Okay, so like how much space different people have in their working memory.
Right, and this capacity is often referred to as their span.
Okay,
And the basic logic is that if someone has a greater capacity in a particular part of working memory, say the visuospatial sketchpad,
okay.
and they do better when they're learning from something that's very visual,
Right.
then that suggests that the VSSP is actively involved in that learning.
Okay, so it's like looking for correlations between working memory capacity and how well people learn.
Exactly.
Okay, that makes sense. So how do they actually measure this working memory capacity or span?
Right. So they use a variety of tasks called span tasks.
Span tasks, okay.
And there are two main types: simple span tasks and complex span tasks.
Okay, what's the difference?
So simple span tasks are designed to assess the basic storage capacity of the phonological loop and the visuospatial sketchpad kind of in isolation.
Okay, so like how much can each of those subsystems hold on their own?
Exactly. So for the phonological loop, a classic task is the digit span test,
Oh, yeah, I've heard of that
where
one.
people have to remember and repeat back sequences of numbers.
Right, and the sequences get longer and longer.
Exactly. And for the visuospatial sketchpad, there's the Corsi block tapping task,
Coursey blocks.
where people have to remember and tap back sequences of blocks that have been touched.
Okay, I've seen that one done before.
Or the visual pattern test, where they have to remember and reproduce abstract visual patterns.
Okay, so these simple span tasks give you a baseline measure of each subsystem storage capacity.
Exactly.
Now, what about complex span tasks? You mentioned those two.
Right. So complex span tasks are a bit more involved
Okay, how so?
because they don't just require people to store information, they also have to do another demanding cognitive task at the same time.
So they have to multitask.
Exactly. And one well-known example is the reading span task,
Okay.
where people have to read sentences and judge whether they're grammatically correct.
Oh, okay.
But at the same time, they also have to remember the last word of each sentence.
Oh, wow. So they have to process the meaning of the sentences and remember specific words?
Exactly.
That sounds tough.
It requires a lot of mental juggling.
So what other complex span tasks are there?
There's the listening span task, which is similar but with spoken sentences.
Okay.
And there's the operations span task, where people solve math problems while remembering a list of words.
Okay, so always this combination of storage and processing.
Exactly.
So how do these complex span tasks relate to the central executive?
So the idea is that these tasks really tap into the central executive's abilities.
Okay.
Because they require people to manage multiple processes at once.
Right, switching attention, allocating resources, all that good stuff.
Exactly. And often researchers will use at least two different complex span tasks.
Okay, why two?
To get a more complete picture of the central executive's capacity, one that typically involves the central executive working with the phonological loop, like reading span or operation span,
Okay.
and one that involves the central executive working with the visuospatial sketchpad, like the spatial span task.
And then they can kind of see the central executive's contribution across these different tasks.
Exactly, using some fancy statistical techniques.
Okay, so that's the capacity approach.
Yeah.
You measure people's working memory capacity using these different span tasks, and then you see how that relates to their ability to learn from multimedia.
That's the gist of it.
Okay, cool. So now let's move on to the dual task approach.
Mm.
What's the logic behind that one?
So the dual task approach is a bit more direct.
Okay, how so?
It's like we're actively trying to interfere with a specific part of working memory
Okay.
while someone is learning from multimedia.
Okay, and the goal is to see if that interference affects their learning.
Exactly. So the basic idea is this.
Okay.
You have people learning from multimedia materials. But at the same time, they also have to do a secondary task.
Okay, a dual task.
Right. And the secondary task is designed to put a load on a particular component of their working memory.
So we're specifically targeting one of those working memory players.
Exactly.
Yeah.
And the logic is that if that secondary task interferes with their learning,
Okay.
meaning they learn less effectively compared to people who aren't doing the secondary task.
Right, a control group.
then that suggests that the working memory component being targeted by the secondary task is also involved in learning from the multimedia.
Oh, okay, I see. So it's like we're trying to see if those two things are competing for the same mental resources.
Exactly. It's like seeing if they're both trying to use the same mental machinery.
And if they are, then performance on one or both tasks might suffer.
Right.
Okay, that's a really clever approach. So what kind of dual tasks do they use?
So there are three main categories of dual tasks that researchers use in this context.
Okay, lay them on me.
First, you have concurrent secondary tasks,
Concurrent meaning?
meaning they're performed at the same time as the learning task.
Oh, okay, so like simultaneously.
Exactly. So, for example, someone might be asked to tap their fingers in a certain pattern while they're reading a text with illustrations.
Okay, so that would be a concurrent secondary task.
Right.
Okay, what's the second category?
The second category is interference tasks,
Inference tasks.
where irrelevant stimuli are presented during learning.
Okay.
And these stimuli are designed to kind of automatically grab the person's attention
Okay.
and therefore interfere with a specific working memory system.
Oh, okay, so it's like throwing a wrench in the works.
Exactly.
And what's a classic example of an interference task?
So a classic one that targets the phonological loop is having irrelevant speech playing in the background.
Oh, yeah, like when you're trying to read and there's someone talking nearby.
Exactly. It's really distracting.
It is, and that's because it's interfering with your phonological loop.
Exactly.
Okay, so that's interference tasks.
Yep.
What about the third category?
So the third category is preload tasks.
Preload tasks. Okay.
And in preload tasks, people are asked to hold certain information in their working memory before or even during the learning activity.
Okay.
So, for example, they might have to remember a sequence of shapes before they start looking at a diagram.
Okay, so they're already holding something in their working memory before they even start learning.
Exactly. And the idea is that holding that preloaded information takes up space.
In the relevant working memory component.
Right. Making less space available for processing the new information.
Okay, I see. So that's the logic behind preload tasks.
That's it.
Okay, so we've got these three categories of dual tasks, concurrent interference, and preload.
Right.
Can you give me some specific examples of how they're used to target each of the different working memory subsystems?
You bet.
Okay, so let's start with the phonological loop.
Okay, so to load the phonological loop, a common technique is articulatory suppression.
Articulatory suppression, what's that?
It involves having people repeat a simple sound or word over and over again out loud.
Okay.
Like the or la la la.
Okay, I see.
And this is thought to disrupt that inner voice that we talked about.
That's subvocal rehearsal in the loop.
Exactly.
Okay, and we already talked about irrelevant speech as an interference task.
Right. Playing unrelated speech in the background.
Right. Okay, and what about preload tasks for the phonological loop?
For preload, they might have to remember a short list of words while they're doing the learning task.
Okay, so they're already holding those words in their phonological loop.
Exactly.
Okay, cool. So what about the visuospatial sketchpad?
Okay, so to target the VSSP, there are a few different approaches.
Lay them on me.
So for the spatial component, a common one is spatial tapping,
Spatial tapping.
where people have to tap a sequence of locations on a grid or move a joystick in a pattern.
Okay, so that's engaging their spatial processing.
Exactly.
Okay, what about the visual component?
For the visual component, one option is dynamic visual noise.
Dynamic visual noise.
So this is basically a display of random black and white dots that change rapidly.
Okay, I can imagine that would be pretty distracting.
It's like a visual version of irrelevant speech.
Right, it's cluttering up your visual field.
Exactly.
Okay, and what about preload tasks for the VSSP?
So for preload, they might have to remember a visual pattern or the locations of dots in a matrix.
Okay, so they're holding that visual information in mind.
Exactly.
Okay, and finally, what about the central executive? How they target that one?
So for the central executive, a common type of task is random generation tasks.
Random generation tasks.
Now,
Okay.
people have to continuously come up with random sequences of letters, numbers, or finger taps.
Okay, so they can't just fall into a predictable pattern.
No, it has to be random, which requires a lot of mental effort.
Right.
And these tasks are thought to really load the central executive because they demand executive attention and the ability to inhibit those habitual responses.
So it's really taxing that control center.
Exactly. And because these random generation tasks can sometimes also involve the PL or VSSP,
Right, depending on whether they're verbal or spatial.
researchers will often use two different versions of these tasks to try and isolate the central executive's involvement.
Okay, so they might have people generate random letters and then also generate random taps.
Exactly.
Okay, so that's super interesting. So we've got these two main approaches to studying working memory in multimedia. learning the capacity approach and the dual task approach.
Right. Two different lenses for looking at the same problem.
Exactly, and it sounds like they both have their own advantages and disadvantages.
Definitely.
So the capacity approach is often easier to do in a research setting.
Yeah, you can usually give those span tasks before or after the learning activity.
Right, without directly messing with the learning itself.
Exactly.
But the findings are mostly correlational.
Right, which means it's harder to say for sure that differences in working memory capacity are directly causing the differences in learning.
Right. Correlation doesn't equal causation.
Exactly.
And also getting a good measure of central executive capacity can be tricky.
Yeah, you often need multiple complex span tasks, which can make the experiment pretty long and demanding for the participants.
Right, I can imagine.
But on the other hand, the dual task approach has the potential to provide more direct evidence.
Or causal evidence.
Exactly, because if that secondary task directly leads to worse learning,
Right.
then that's stronger support for the idea that those mental resources are being shared between the two tasks.
Right. Okay, so it provides more direct evidence, but it can also be more difficult to implement.
Exactly. You need to make sure you have a reliable baseline performance without the dual task.
Right.
And choosing the right dual task that specifically targets the right component without messing things up is really important.
Right. It's a delicate balancing act.
It is.
Okay, so we've covered the theory and the methods. Now, let's get into the actual research findings.
Let's dive into the data.
What have studies using the capacity approach found about the role of working memory in multimedia learning?
So the capacity approach studies have given us some really interesting insights.
Okay, tell me more.
So for example, research by Geislink and his colleagues,
Okay.
they found that people with higher visuospatial sketchpad capacity seem to benefit more from learning materials that combine static pictures with text.
Okay, so if you have a good visual spatial sketchpad, you're better at learning from text and pictures together.
Exactly. And interestingly, these same high VSSP people, they were more disrupted when they had to do a spatial tapping task while looking at the pictures.
Oh, wow. So doing that spatial task interfered with their ability to process the pictures.
Exactly.
So that really suggests that they were relying heavily on their VSSP to understand those visual.
Exactly. And on the flip side, they also found that people with higher phonological loop capacity did better with text-only materials.
Okay, so good PL equals better text processing.
Right. And those people were also more affected by articulatory suppression when they were processing text.
Which makes sense if their phonological loop is already busy processing the text, then trying to repeat those sounds at the same time is going to cause problems.
Exactly. It's overloading the system.
Yeah. Right. So this really supports the idea that the phonological loop and the visuospatial sketchpad have distinct roles.
Separate but important roles.
Right. And that they're both involved in multimedia learning.
Exactly.
Okay, so what other patterns have they found using the capacity approach?
So other studies have looked at the role of central executive capacity in multimedia learning.
Okay.
And for example, Patsalia and colleagues, they found that people with higher CEPL capacity.
So that's the central executive working with the phonological loop.
Right. Measured by those complex span tasks.
Like the reading span task.
Exactly. They found that those people learned semantic knowledge better from a hypermedia system.
A hypermedia system.
Which is basically a network of information that often includes text, images, and other media.
So like a complex website or a learning platform.
Exactly. And it requires a lot of navigation and integration of information.
Right.
So people with higher CEPL capacity were better at extracting the meaning, the semantics from that kind of system.
Okay, that makes sense.
And in contrast, their CEVSSP capacity, so that's the central executive working with the visual spatial sketchpad,
Right.
that was more related to their memory for the structure of the hypermedia system.
So like remembering the layout, the map of the information.
Exactly.
Interesting. And what about those simple span tasks that just measure the basic storage capacity of the PL and the VSSP?
So those tasks didn't show as clear a relationship with these learning outcomes,
Right.
which suggests that the central executive might be more important for those higher level processes.
Like integrating information and building a coherent understanding.
Exactly.
Okay, so that really fits with the idea of the central executive being the conductor, the one making the connections.
Right.
Okay, so have there been any studies that specifically looked at how central executive capacity interacts with different kinds of multimedia presentations?
Yes, definitely. So studies by Austin and by Doolittle and his team,
Okay.
they found that central executive capacity, specifically the CEPL component, was a significant predictor of how well people could transfer what they learned
Transfer meaning...
Meaning apply what they learn to new situations.
Right, okay.
But they didn't find any interactions between CEPO capacity and different multimedia formats.
So like animations with spoken text versus animations with written text.
Exactly. So it seems that a higher CEPL capacity is generally beneficial for learning and transfer, regardless of the specific combination of text and visuals.
Okay, so that's good news for people with strong CEPL capacity.
Absolutely, they have an advantage.
But were there any studies that found a more nuanced effect?
Yeah, so a study by Sanchez and Wiley, they found something interesting.
What's that?
They found that people with lower CEPL capacity were more affected by the presence of irrelevant pictures.
Some distracting pictures.
Exactly. So